Hello, everyone. My name is Patrick Wojniczka, and I'm one of the Toronto Dynamo user group founding members. I'm a computational design specialist with background in architecture. I'm currently working at this very cool engineering firm called Intuitive, which is also sponsoring this event. You probably know us already, but if you'd like to find out more, feel free to reach out to me after this or anytime. Our panel is about digital fabrication, and to warm us a bit, I prepared a few slides with some basic digital fabrication techniques. It's mostly to get us all in the same thinking space, to help us think in the same terms and prepare for the upcoming presentations from our panelists. So digital fabrication can be defined as any manufacturing process controlled by a computer. One of the most significant benefits of the introduction of digital control into fabrication technologies has been greater accuracy and precision. In other words, to take the full advantage of the power of computational design, we need to start fabricating digitally. So some of the techniques include additive manufacturing. That is, it's often called 3D printing and refers to processes where materials are deposited layer by layer. And materials can vary. It could be concrete, it could be steel, or some other more sophisticated materials. And then we have subtractive manufacturing. That refers to processes where objects are constructed by successively cutting material from a solid block. Another category is robotic manipulation, and that includes other digital manufacturing operations such as forming, bending, folding, stacking, weaving, and stitching. Here's an example of robotic coreless filament winding. An interesting example of robotic manipulation is the robotic autonomous assembly, where various types of robots assemble architecture autonomously. Material programming is a paradigm in which complex properties of various materials are driving the geometry and configuration of architectural and structural artifacts. Another interesting paradigm that lies on the intersection of traditional and digital employs virtual reality to assist traditional manufacturing techniques. Here, for example, digitally assisted bricklaying. The digital fabrication is happening at various scales. So from a scale of a pavilion to a scale of, from a scale of pavilion or a sculpture to a large scale or even mega projects. It's happening at academia. It's prevalent there, but it also transpires or is connecting to practice. And it's happening also at large scale. Dynamo and Grasshopper are just some of the many computational paradigms that probably most of you are familiar with. And just to reinforce this, hypothesis that we actually need to start doing this, the digital fabrication, I would like to use a quote from a recent publication that wide-scale deployment of any architectural optimization strategy is foreseeable only under the assumption of a radical innovation in construction technology as well. And this helps bring the architecture, engineering, and construction into a symbiotic relationship.